Hello, this is a video to show you how to set up the Boxx Meridian system. This is the first video showing the OB receiver and how to set it up. With me is Gareth Buss from ITV Studios, which is where we are today. They've had a system for about 6 months now. You've got a few hundred hours under your belt using it live to air, live to tape. So I thought what better person to bring into this instructional video than someone that uses it every day. So Gareth, we have the system set up here. Take it away, tell us what you do.
Yep, okay, so what we do is we lay out all the gear that we're going to use first, just to make sure we've got everything, and we don't need to get any other bits missing or anything like that. So we've got the three 2020 antennas that you supply. We only actually use 2 of them, so we've got 1 spare. And we've got the 5 205 antennas here, the smaller ones. We only actually use 3, so we've got 2 spares of those as well. And then we've got these coaxial knuckle joints that we use to actually attach the antennas to the receiver itself. We've got a 12-volt power supply with a female XLR there, and we've got a clamp so we can fix it up to a gantry, or in this instance today we're going to rig on a lighting stand just to make it a bit easier for us, and also make sure we've got a decent BNC as well.
And this is cable that's designed to carry HD SDI.
Indeed, yeah.
You have to be a little bit careful there. Sometimes older cables, older coaxes aren't spec'd to actually carry HD, so make sure that the coax is spec'd as a HD SDI if you're using HD. Okay, so the first thing we'll do is to explain exactly what do these connectors do. So starting from left to right, the first one we have spectrum analyzer. We can build a spectrum analyzer inside the unit that allows you to go through and look at the spectrum to allow you to choose which is the best part of it. There's actually a separate video explaining exactly what that's about, so have a look at the spectrum analyzer video. The second one is USB control. That's used to do firmware upgrades. So once we release new firmware, you can connect that to a PC and upgrade the firmware. Second, or third and fourth is data in and out. That's used to daisy chain the receivers, allow you to increase the range by using multiple receivers. If you want more information on that, call us at Boxx and we'll explain how that works. So next is tally. That's used for our tally iris only product that allows you to do a tally light and just control the iris of the camera. And again, there's another video explaining exactly what that's about. Next is the control panel that allows you to control the unit, and we'll go through that in a moment. And then we have all the BNCs that allow you to take component out, SDI out, composite out, and Genlock in when we release that in 2012. The composite output allows you to monitor any HD signal. It's actually down converted, and it's designed just as a test port, so you can localize or locally monitor a HD signal on a composite standard monitor. In our newer models, we also have a small LCD built into the receiver that allows you to monitor the picture locally. So on the other side, we have the 7 antenna inputs, 2 receive antennas. We then go to our uplink, and again, that's used for the tally iris only system, which again is explained in the tally iris video. Third antenna, the spectrum analyzer, which is explained in the spectrum analyzer video, and we have the last 4 and 5 receive antennas. So Gareth, do you want to go through and explain to us how you connect to the antennas up?
Yep, sure. So I always attach the knuckle joints to the antenna first, just because it makes it a little bit easier to get it on. And then I should explain, we always rig the antennas down on the floor first because we don't want to be doing it above people's heads. So attach one end to the back of the antenna there, and then attach the other end onto the back of the receiver there.
Now with these connectors, these are an N-type connector. Just be a little careful. You can cross-thread these. They're fairly good, but if you do get them in the wrong angle, you can cross-thread them. And when you think they're actually connected and they're tight, they're not connected at all. So just be careful you get them straight on and you get them nice and tight. There's also a spare adapter we put in the kit as well. So if you lose one, you've got a separate one there as well.
Put them any old way for now because we're going to adjust all the angles of them in a second anyway.
Just one thing to be aware of, the end types on the receiver are not centered, so there is a front and back to the unit. The end types are on one edge, and so that's the front of the unit, and the side the antennas actually point. So just be aware that they're actually not centered, they're actually on one side, and make sure you have the antennas facing in that direction.
Okay, so now we've got all 5 antennas on there. You can see they're all a bit sporadic at the moment, but we're going to sort that out when we put it on the stand.
Okay, so that's all the antennas on.
Yep.
Should we grab the light stand?
Yep, and we'll rig it to the top of that, just for convenience for down here.
Okay.
I'd say normally we'd rig it to the gantry in a studio.
So normally you would put it up on the up top
around the whole
studio.
of this studio, we've got a lighting gantry where the spot ops all go. So we would normally rig it to that with that C clamp that you've got there. But yeah, just for demonstration purposes, we'll just rig it to the lighting stand here. So right now we've got the antennas on. We want to make sure that we get all the coverage. Yeah.
So the difference between Meridian and more traditional COFDM products is that we're using a technology called MIMO, multiple in, multiple out, and it's very important for the system to work to its optimum performance. Is to make sure that every antenna is seeing a difference, or seeing a different part of the signal. So there's no point in having all the antennas facing the one direction and looking straight down to where the cameraman is or where the Steadicam is. What you need to do is to have these in a certain different directions, so we pick up reflections, pick up multipathing. We want to pick up the primary signal, but we also want to pick up the signal as it bounces off a wall, off a light, off parts of the set. So you want to create an environment where these are all looking in different directions, in different polarizations. The most random setup that you can make always works the best. And that's the real key to this technology, is by having different parts of the signal being captured from different directions makes it incredibly solid, incredibly reliable product.
When we're in a studio, we have to make sure that we get the polarization right on the system. You can see on the back here the arrows showing the spread of the signal. So this one here you can see is going vertical, as is this one at the moment, but we are going to sort all that. You can see the direction of the arrow, which way the signal's going. And also you can tell on the front as well, because these arrows, these lines are relative to that as well. So the central one I'll start with, we want that one to be horizontal polarization, so the signal's going out widthways. And then the two inner ones here, they both want to be vertical, so just move those around and get those working. I should point out as well that when you do move them around, it does loosen the joints. So once you've sorted it and got the angle that you want, make sure these are then done all the way up again, because they will come loose. Then we've got the two large 205 antennas, 205? Sorry, the large 2020 antennas next. These ones want to be pointing upwards in our studio because we've got a solid metal grid. So we want to get the signal bouncing off that as much as possible. We've got the grid and also got the gantry as well. There's a lot of metal in the studio where the signal can bounce off.
Okay, so that's the antenna setup. The next thing we would do is give it power through the 4-pin XLR, 12 volts in. You can run that off either a power supply or off a mains adapter. The next thing we'll do is show you the screen, I suppose. What do you do there,
yep.
Gareth?
So once we've got power, we want to make sure that we are set to the correct frequency, which is, as you can see on there, 5.18. That's a channel that we know is safe in the studio. It's such a high channel that nothing else is going to be anywhere near that. So you can see on here that the bars are not moving and the numbers aren't changing, which means there's nothing transmitting on that frequency.
And that gives you an indication there's nothing else on that channel, and that's a good channel to use. If you want to be more accurate than that and actually look at the spectrum in more accuracy and over time, the spectrum analyzer piece of equipment allows you to do that, and that's explained in the spectrum analyzer video. I'll just put the transmitter on without the antennas, and that will demonstrate what interference would look like if you did have it. So that kind of level there, if you had bars slightly coming up like that, that would give you an indication that there's something else on that channel, either another Meridian or a Wi-Fi device, and that would be a channel not to use, to avoid and changing to a cleaner channel. So that's the end of the video showing you how to set up the OB system. We also have a video showing you how to set up the transmitter, the full telemetry system, our tally system. We also have a system where you can do a tally iris only product that allows you to do a very inexpensive ability to control the iris and a tally light. And there's also a video showing you how to set up the system on a Steadicam rig.